Good evening, everybody. Can everybody hear me okay?
Yes.
We're going to do our best to do the microphones so everybody can hear and it gets picked up on the recording. We have a lot of people who are interested from Taos but couldn't make it. So we're going to share it as best we can because this is a great opportunity for actual real life. How does it work here? I'm Abby Hayward. I'm the Water and Energy Conservation Coordinator for the Department of Public Utilities. I do my best to provide outreach and materials for people who are looking to either improve their efficiency, do conservation, maybe lower their utility bills, etc. So we are here to provide resources for you, our customers. So if you think of any opportunities for outreach you'd like to see us do, please let me know. Because I just fly by the seat of my pants sometimes, and we had a lot of questions for heat pumps, and this seemed like a good opportunity to provide that education from, not from Google and me, from people who actually have one installed. So, and from people like me who want one someday. So I'm going to get started. We have 2 more panelists that might show up, but they may very well have had other things come up. So you have 3 very good resources here. I do have a handful of questions that came in online, in addition to any questions you all have. Maybe we'll start with you here since you're here. So thank you for taking the time in your night to come and join us. We're going to try to wrap up in about an hour. So do your best to keep your questions short and maybe not as technical. But feel free to grill Steve. He knows what he's talking about. I'm going to give our panelists just a few minutes to introduce themselves, their names, their system, a real broad overview, and maybe why they elected to switch to a heat pump from whatever system they had. So,
do I start with these? Is this what we want? Hi. Yeah, I'm Steve Booth. I live on Canyon Road, right on the corner of Canyon and 15th Street. So a government house, group 17B. You may know these 2-bedroom, 1-bath homes. Gas furnace in the furnace room, and then the supply ducting in the crawl space and the return ducting in the attic. We lived with this one winter. It would wake us up at night when the furnace would kick on, blowing dust around, and we have asthma in the home, so it was time to move to a heat pump. So we moved to a heat pump. We have a 3-zone heat pump. That means a single outdoor unit with 3 individual heads inside the home, 1 in the living room kitchen, and then 1 in each of the bedrooms. And it's been working out great for us for heating as well as cooling. I was actually able to get rid of my gas meter. The county came and took the gas meter away and capped the line. So it's an all-electric house, 1956 vintage 2x4 home.
Can you tell us more? No. So my name is Gilles Busseau. I live in White Rock on Valle del Sol Road. And I have a passive solar house from the 80s. Oh, sorry. I'm going to scare myself. I have a passive solar house from the 80s. And so I didn't have any heating or cooling because, first of all, in the summer, my walls are very thick and it stays cool all summer. And then in terms of heating, however, these past few years, in the winter, if there are a few cloudy days in a row, we would wake up to 56-degree temperature in our bedroom and the rest of the house. And so my wife threatened a divorce unless I did something about it. And so I started researching this. And because the house is sort of an open concept, there are no doors between rooms, with the exception of bedroom maybe, but and also high ceilings, and it's 3,500 square feet or something. I really didn't know how to tackle it, and then I did some research, looked at heat pumps, and what attracted me specifically was the modular design, and whereby there's a very single control system with a fan system and a compressor, and then the units are individual units within that you can place in different rooms, and so that allows you to basically heat rooms individually or together. You have the choice, but the advantage of individually is that you don't have to heat the whole house to have heat, and that's where, for me, the energy savings probably comes from, for the most part, compared to other HVAC systems. Anyway, so I have 5 units in 5 different rooms, and because the rooms are interconnected, I have them so that they flow into the room from one unit, but then go into the next room. And so I position things through Steve, who was my favorite go-to consultant, given he explained absolutely everything, and I got to have great discussions with him about it. And he designed it so that the ones that were in one room were also heating peripherally another room on one side, and another one away heating the same room also peripherally to the main unit. So let's see, I think that's all I have so far.
Or you want to use this one? Doesn't matter.
Whatever you want.
Doesn't matter.
Hi, I'm Sue Barnes. I've been a resident of the historic Denver Steels since 1996. For those of you who don't know, these were prefab houses that were put in the 1950s. They were never meant to be permanent structures, and they were originally 732 square feet of house. My house has an addition on it for 1,200 square feet, but when we moved in 96, it had the original in-floor gas furnace, which was basically just a big burner in the floor with a grate over the top of it, completely passive. It just sat there and burned gas, and for 732 square feet, it was adequate. But then they put an addition on the house. They didn't put in any heating except for a wood stove, and we lived in that situation for about 20 years with electric resistant space heaters in the areas that were not served by the gas boiler. But it became clear to us that was not very well, it was never very comfortable. There were times we just didn't go to the parts of the house that had the space heaters in them. We just stayed in the part with the furnace. We were concerned that if it ever broke down, that it was a 70-year-old unit, there would not be parts available. We knew it was horribly inefficient. We could smell gas when we came into the house from time to time, even when it was off. You always had to have the pilot light burning. It was never very comfortable, and it just wasn't a great solution. Also, we noticed that it was getting hotter in the summers, as you all may have noticed, and so air conditioning started to seem like a very attractive option. And so in 2016, 8 years ago now, we installed a Fujitsu unit, sounds similar to Steve's set up, 1 exterior unit, 3 interior units, mini split system. And it's been terrific. And for a while we kept the gas burner hooked up, just in case, because we thought we might get cold or it might not work or something like that. But after 3 or 4 years, it wasn't. We weren't using it. We never turned it on. And so we had the gas shut off and immediately saw a 50% reduction in our gas bill because that pilot light apparently was using a lot of gas. And we've been very happy with the system ever since. It's quiet, it's efficient, gives us air conditioning, which for a few weeks out of the year makes it possible for me to sleep. And the heating has been terrific, and that's what I know.
Great. We did have one of our other panelists did use their heat pump system primarily for cooling. So it's unfortunate that they couldn't come because they didn't put it in for the heating replacement. So that's just something to consider, that if your heating system is newer or you recently replaced it and you're going, shucks, fear not. That could be something that you either use as an alternative, or for cooling, we've been trying to just push out information that a heat pump's good to consider because it's one unit to do maintenance on, and you're not doing maintenance on an AC unit and then a furnace, for example. So unfortunately they couldn't come, but we will move on. Do you guys want to start with audience questions, or do you want me to ease you into it with my submitted questions? Okay. Does anybody have any burning questions? I'm going to walk around with this. Just so everybody can hear you.
Yes, my name's Tom Ricketts. Sue, I have a question for you. You've had your unit for 8 years. Any issues?
Yeah, you can try that. That way we can. Should be good to go.
Okay, there we go. So the only issue that we had actually turned out to be a somewhat major one, and this would be a caveat. When we had the system spec'd originally, when we had the space evaluated to see what size unit we needed for the amount of space we needed to heat and cool, we were right on the borderline between two different size units for interior and exterior. And I had read on the interweb about how, they'll try and oversell you a system that's too big, so don't go for that. You can get away with using a smaller one. And so to be cheap, I went with a smaller one. And after 6 years, it started making a horrible noise. Some of the bearings started to go. And after a year of that, we had it replaced. With a larger unit, which has been fabulous so far. And it's...
I think it's cutting it out.
Oh, okay. It's not entirely clear that it was because we undersized the unit. It could have been a faulty unit to begin with or whatever. It was still under warranty, which was nice. So we were able to upgrade to the larger unit with a little extra cost. And now, actually, if we wanted to put in additional interior mini-split units, we could, because we have the larger unit. So my caveat would be don't undersize. Oh, that's really straightforward. You take out the little filter screens from the interior units. We try and do it monthly when we're using it and vacuum them off. And then for the first few years we had them, the people that installed it were willing, included, checking maintenance and checking and that sort of thing. And they did, but they didn't do anything. They just checked it, and we haven't been checking it since then.
No maintenance except for those filters.
Yeah, maybe Steve will tell us we should be doing something more. No, good. That's good. So, no, we just vacuum off the little filters.
I heard the term mini split. I'd just like to know more about what that is.
Mini split.
So the word mini split comes from the idea that it's a small indoor head. You've heard of central AC, central heating, indoor unit sitting on a wall or in a ceiling. So a traditional gas furnace is a central gas furnace or central AC, central air conditioning. That is called a split AC, where it has an outdoor condenser, a cube-shaped condenser, and refrigerant lines come into your furnace room where there is a AC coil, an air conditioning coil, placed in the furnace so that the fan can blow cool air through the ducting during the summer. That's called split AC. Mini split sort of gives you the idea of, instead of one central AC coil sitting in the furnace connected to one big unit, you now have small mini split ACs that are scattered across zones in your house. That's why the word mini split. It's not a big coil in a furnace that might be a 48,000 BTU coil. It may be a 12,000 BTU coil in the kitchen and a different size one in a bedroom. So they're mini split. MINI split. That's where the name comes from.
But they're air conditioning and heating.
Exactly right. They can, they do both heating and cooling through the same coil in that unit sitting inside your room on the wall or in the ceiling or on the floor, wherever you put it.
Are they all individually plumbed as far as the mini split? So for each room and not centrally, supplied?
That's a good question. The outdoor unit is your condenser, the outdoor condenser, and then from it come the umbilical cords, you might say, or the refrigerant lines and communication cables and the electricity comes to each of those individual mini split units in every zone, every room.
There are systems that you can replace, like a forced air system. They do operate differently with if you have ducting that you really want to keep. It doesn't do as individual control without a lot of upgrading to your ducts. Like if you still wanted to keep your bedroom at one temperature and your bathroom at another, you'd have to put these little like sensor things on that do flappy doors, and it can be more involved. But if that's something that you really want to keep, that is an option.
Like that, just have floor burners.
Okay, that is a question I'd received. Are there? Yeah.
Yeah, I guess my interest was the economics compared to gas. I was talking to Steve earlier. My experience was 35 years ago, I moved to Raleigh, and they had time of use. It was a private utility, so they were interested in efficiency and economics. And so I had 3 heat exchangers for 4,400 square feet. Heat pumps, which ran at 3 cents per kilowatt hour, because at time of use, I could run the heat pumps at 3 cents a kilowatt hour, and there was enough thermal inertia in the building that I'd run, and I use Fahrenheit, I'm sorry. I mean, I don't use Fahrenheit. I would run it at about 19 degrees in winter and 24 degrees in summer, air conditioning, and all the time at 3 cents a kilowatt hour, because the utility had an incentive to level, and they had nuclear power plants which could generate at 3 cents a kilowatt hour, and it saved them peaking plants, so it saved them also from capital investment in peaking plants. Yeah, but my question really is, which I also submitted online, is have any of you done an economic analysis at, say, here, 12 cents a kilowatt hour, roughly, versus whatever gas. Now, gas prices are, but one of the many gas prices we've had. Has anyone done an economic analysis? The heat pump, by the way, I found at -5, -10 degrees, the heat pump had resistance heaters had to cut in. You know, and I did some thermodynamics, which was done in kelvins, but basically at the loads I was, it became equivalent to, the heat pump was as inefficient as a resistance heater when you got around -10.
Do any of you want to tackle the?
So, in my case, I don't have that because it was installed in the spring. But one thing that I know is that the economic advantage will depend on individual installations. So my house is very well insulated, and so it doesn't take much for an economic advantage. Plus I have solar panels, and they kick in because it's an electric-based system. And the only other thing I can say is not having ducts is really good, because you don't have any loss of heating that you have in ducts. The lines come in, there's no loss of heating through the refrigerant lines. And finally, there's less maintenance and no mold, because that's where the ducts come in again. Of course, in New Mexico, it's dry. There's not that problem. But, if you're in a humid environment, the ducts are where the mold can come from, and this is free of that. So in my case, it's extremely efficient, and I expect it won't. But it'll cost me more because I had nothing before. right? But that's not the measure that I want. I want clean air and warm or cold, depending.
But you know, Gilles, you also forgot you wanted to stay married.
Right. Okay. Yeah, I try to forget that one, but.
So I'm actually trained as an economist, but it's difficult to do the economic analysis in this case. Every home is different, and what I find is my home. What I find is, as soon as you get one of these systems in, it changes your lifestyle. Gilles already talking about how he's not going to keep a house at 56. He's going to keep it at 68 or 70, whatever he decides. His bedroom might be 60, 65, but his living room could be 72. So the way to look at this is New Mexico, what a wonderful state. We're an energy producing state. Our natural gas prices are about 50% of the national average price. So we're sitting on a gas patch. Our electricity is less expensive than the national average, maybe 70% of the national average, so that's wonderful. But it's hard to beat natural gas for heating when you're in New Mexico. It is pretty inexpensive. So don't think about heat pumps to say, I'm going to save money on my gas bill. Think about it as, I'm going to be able to sleep better at night because I have control in my bedroom. I don't have a furnace that wakes me up when it kicks off and on, which they do. This will be essentially quiet, 19 or 20 decibels, steady state, you'll sleep through it. So it'll cost a bit more, let's say during the winter, but then during the summer you've got full air conditioning. And in the summertime, it's super efficient because we live in this wonderful climate also. It's not Phoenix, it's not Miami. So you may be able to see one latte per month out of Starbucks additional bill in the summer, but that's about it. It's hard to find it in your summer bill. I've tried. It's hard to find.
I have a heat pump for air conditioning. I've used it 2 days this summer. I use it for air conditioning by opening the windows at night, closing it at 9:30 in the morning.
So that is a good point. Don says that in Los Alamos we have the wonderful cool evenings. It drops to 63 when the sun goes down. Turn on your whole house fan, blow it through. But if you have a forest fire in Las Vegas like 2-3 years ago, you cannot cool the house down. If you have asthma in the home, we have asthma in the home, you just can't open the windows. And now I've got a 1956 vintage home. I can't get cool, can't sleep. That's the problem in my house. One more point about this, I would say, actually, I'll move on. Sorry, guys.
I will bring up one point. For those of you who are just curious about what it might cost you, we do have a calculator that somebody put together where you put in your heating system. It'll default to a location. Right now it defaults to Albuquerque, but we can provide you the heating degree day information that you can fine tune it a little bit, and then you select the system you want to go to. So you can pick boiler to heat pump, you can pick Radiant Florida solar thermal, or whatever system you want to consider, and it'll give you a very rough calculation because it's based on cost of gas and cost of electricity. So that's something if you want to prepare for what it could be. And then I'm glad you guys brought up kind of the quality of life. I just went through the electric coach training through Rewiring America, and they always talked about nobody goes into your kitchen renovation and says, what's the cost of return on your $20,000 kitchen renovation, right? So if you think about kind of what are you doing that upgrade for, if it comes down to dollar and cents to you, that's great, but otherwise it should just be for quality of life. And do you want a more comfortable home? Do you want a more thermally compatible home? Do you not want my 2-year-old to be woken up by the furnace? So, yeah.
Thank you all for coming today and being panelists. I'm in a small little condo, and so I think the only spot where our heat pump could go is like right by our outdoor patio. So I was wondering what the sound amount was, like if in the summer, if we're out on the patio, like would it be annoying, like loud, or what that looks like?
I'm going to add on to her question also about the breeze that blows out of the unit on top of the sound for each of you, how that's placed.
That's the sound I hear is really just the breeze. Sorry, the only sound I hear out of my units is the breeze coming out, that's telling me it's on, and it doesn't bother me because I want the breeze when I turn that on, so. Yeah, the mini splits. Yeah.
He's talking about the outdoor condenser. That's what we're talking about, an outdoor condenser on the patio. So if you look at the specifications, you can see online what each outdoor unit has as a maximum sound pressure level when it's running maximum full blast. And some units, most units are around in the low 50 decibels. So about 53 or 54 decibels when it's on maximum 100% moving of air, and that is normal human conversation. So normal human conversation, you can hear someone maybe standing outside your sliding glass door talking. You're not maybe going to hear their words or diction, but you'll know somebody's out there. That's when it's running full blast. But most of the time it's going to be modulating and running maybe 30%, or the fan may be turning this slowly. So there's no air pressure. The final question that you had, Abby, was that breeze coming out. Recognize during the air conditioning season when you're out on the patio, it's blowing hot air. So your patio is not going to be 82 degrees, it's going to be 85 degrees. If you stand in front, it's going to be 87 degree air blowing at you. And it's the opposite in the winter, right? So if you try to do something out in front of that fan in the winter, it's going to be blowing out 20 degree air. It's very uncomfortable in the winter for sure.
I wanted to just briefly mention that the mini split kind of situation we're talking about here is one configuration of heat pumps. There are also ones that are available now that are particularly useful in apartments and that sort of thing, where it's sort of it's a window unit, and the inside the two pieces just basically drape over the windowsill in your room. So that might be an option for smaller spaces like you're talking about, where you wouldn't have this larger outdoor compressor concern blowing on you. So just know that there are other configurations of these that might work better.
I just wanted to say, oops, is this on?
Yeah.
Yeah, I just wanted to say that I have one of these systems where, because I have 5 mini splits, it's a pretty large one. And my neighbor right across had an air conditioning system, and I could hear the air conditioning. And so he was going to change it. So I sort of tried to talk him into getting a heat pump. Now he has the same thing as I do facing me, and I don't hear anything anymore. And so, in terms of sound difference, it's pretty substantial in my case, at least.
Pete, on the question?
I've heard that it's not as efficient if you turn it down at night like you do with a regular heating system. Is that the case? And how much really will that cut into your efficiency?
Yeah, traditionally I was taught by my father to turn out the lights and turn the gas thermostat down when I go to bed, because you're not going to use it. Now, heat pumps like to be running all the time. It's a different way of thinking about it. These units they're modulating. So instead of running 100% when they're on, they may be running at 30%. And then go into standby and then run only at 30%. They only bring refrigerant to those indoor units when it's needed, and they're constantly sensing the air temperature in your zone and checking the set point versus the actual temperature in the room, and only giving you enough fan speed and enough refrigerant to handle that delta T, that delta temperature. So when I first got my 3-zone system, I was trying to optimize as all folks in Los Alamos do. You program the heck out of your remote, you change it 4 times a day, 7 days a week, and have a great time. But the problem with that was I'd get up in the morning and it was cold in my little government house that has a bank of windows facing north. So the living room was 62 degrees or 61 degrees. Then I'd turn on my unit to 70 and it would work for 4 hours, not at 30%, but maybe 75% capacity, pushing, trying to get the room back to something close to 70 degrees. So I wasted those first hours in the morning with a cold situation, but also I burned a lot of more electricity when the unit was working. And now I keep it at 68 all night and 68 during the day. And when I get up in the morning, it's 68. And the machine is barely turning. You know, it's not working hard during the day. It does burn some at night, but now my sheetrock, my floors, my ceilings, my joists, everything is at 68 degrees. You know, you can take a measurement on it. The mass of the house is at 68 degrees. I didn't let the mass go down to 61 and then attempt to raise the mass of the house using molecules of air pushed around by my heat pump. It's difficult for air to heat up that sheetrock. It takes a lot of hours. So now my house is more comfortable in the morning when I'm having my cup of coffee, and I think it's more efficient too. It's hard, again, it's hard to do a true full winter 3 months with all the temperature degree days. I just can't do it. There's so many variables, but it's what I'm told by the experts is the way to run them.
Yeah, and I didn't try that because I'm at the stage where I'm turning it on. You know, you know what? I want just my bathroom to heat up, so I'm turning it on, and in 5 minutes or less, boom, I'm at any temperature I want. And I think just from this winter, this is my transition time. I'm going to try it the way Steve had recommended way back in the spring, but this summer I didn't use it, so now I'm going to try it. But that is a hard concept to accept, is, you know, leaving it on versus, oh, I'll just turn it off and I'll only turn one on and not the others, and etc.
I'm going to interject real quick. So one of our submitted questions was, how do you feel about the adequacy of heating? This person didn't feel like their heat pumps was providing enough heat in their house, and that very well could be a behavior change that needs to be done. I read a report of this reporter was using the heat pump for cooling, and it was the same thing. They were dealing with 90 plus on the East Coast and going, my heat pump just can't keep up. And they waited too long to activate the heat pump because now your house is trying to combat 90 inside, and it's just working its little butt off to cool your space down, and you're going, why isn't it working? Well, you're putting it into overdrive, and it just can't keep up with what the house is already at. So you do need to pre-plan, I think, a little bit with what the forecast is going to tell you to do if you don't turn it on or keep it on all the time because your house is a warm blanket already. So let's hear what Sue does.
Oh, that's the hardest habit to break, the turning it off at night thing. But yeah, we've done it both ways, and indeed, it is delightful to wake up in the morning and have a warmth, the house be the same temperature it was when I went to bed. And I've also read some reports because I had a hard time making that transition, that told me that that was the most efficient way to use these units, is just to let them run, let them keep everything warm, and that way also you're not overloading, you're not trying to use the maximum amount of energy when everybody else in town gets up and uses the maximum amount of energy to heat their homes. If you just keep it where it needs to be, and wake up to a warm house, it's lovely. But it's a hard thing to do.
And as I walk to the next question, we are trying to pull they've given consent to pull their utility usage so we can see that in a story. I'll keep them anonymous so you won't know whose is whose. But it's easier to help see that, right? Like, when did the gas usage stop? I like to share my own of when our insulation, we put attic insulation, you can see our gas consumption just plummeted. And I still have my gas furnace, so it's still operating, but even insulation. So to show people the stories of these conversions through their utility usage is better than, well, it's also helpful in addition to these people going and telling you their story physically. That way you're not just like, you're just telling me stories. So it's actual hard data. I'm going to go back here.
Thanks, Abby. Is it on? It's on. Okay. So I had one question, but now I need to follow up on this last answer to Katie's question. So am I hearing you say that you kind of want to keep it constant, say choose 68, or you could choose 70, whatever's appropriate for your household. But what if you really want your bedroom like at 65, but you want the house at 72 when you wake up, and maybe your bedroom's on a different floor? Is that can you do that?
Ooh. Let me answer. That's the best part. Each of these mini split units that's in each room are separately controlled with their own thermostat and their own controller. Because, yes, so I sleep at 65. When I'm awake, I like it at 70. I can set each room to the temperature that I want it to be at. And that also, I think, makes for greater efficiency as well, because you're not pumping 70-degree heat through your whole house when you don't need that kind of temperature in all the rooms. So that actually is one of my favorite parts about having a heat pump.
What if you're not getting mini splits, if you're using your existing ducts, if you're just getting one unit?
Well, I think Abby talked a little bit about how you can jigger the ductwork thing. Yeah.
Well, thank you, Sue. And then my first question was going to be, if we're in that camp who our boiler died in 2019, and we needed a new thing stat, so we got a new gas boiler, and then in 2020 learned about the magic of heat pumps and regretted it. So here we are with this 5-year-old boiler. Doesn't make sense to replace it for heat. We'd like to have cooling. Do they make heat pumps that really are just for cooling? Are we overpaying for capacity, but oh well, that's just the way it goes for the benefit of the quality of life to have cooling?
So there are two technologies out there in the heat pump world. One is the standard heat pump that Don Dujak was talking about from 30 some years ago in the mid-Atlantic states and in milder climates. It works great. It adds a little resistance heating coils to take care of the cool winters if it were a bad storm coming through. There are also heat pumps that are for low ambient temperatures, which is what we're now seeing through Northern Europe and Maine and Los Alamos and Minneapolis and those places. So you have a choice to go with a standard heat pump, which is a little less expensive, does all the air conditioning you could want. It has full 100% of its heating capacity down to around 45 degrees Fahrenheit. It continues to operate down to around 5 degrees Fahrenheit, but by the time it's that cold, it'll have only half of its heating capacity. So you're going to want a primary heating source in your home like your boiler. But it'll be great as a supplement. It'll be great as an addendum to each zone. And during the shoulder season, it'll be all you need, right, until it gets really cold. And then it has the air conditioning. Okay, so you always have a choice. If you want to go the low ambient route, if you're going to go primary heating source, you'd better do that, because that'll have 100% of its heating capacity all the way down to 5 degrees, and now you're good. That's what my house has. I have to have that because I don't have a gas meter anymore. I have to have the low ambient or hyperheating technology.
Anybody else? Okay. Go back here and then I'll get you.
Two comments. You're asking about an economic analysis. I tried to crank through the numbers, and it seems to me to get 1 therm of heat into the house, if the price of gas is less than about 7 times the price of electricity, are 80% efficient gas furnaces cheaper. And the way it is now, electric is more expensive than that. So the electric is more expensive to get one therm of heat into the house. Yeah. The other question about putting a compressor on a patio or something. We had ours put on the roof, and I regret that. I think it's because of the digital control in the motor. We get some vibration, so under certain load conditions, you can really hear it in the house, and that might be an issue if it's on a porch structure or something like that. But you can put them. I don't know if you have community space or if you can put it down on the ground and just run your pipes a fair distance, 20 or 30 feet probably.
Pipes can be run around 80 feet, 70 or 80 feet. So you have quite a flexibility there.
Did any of you look into heat that pumped from the ground, from the earth, rather than the air?
Very good point. We're talking about air source heat pumps tonight. And what Don has just mentioned is a geothermal heat pump where you do a vertical well 20, 30, 40 feet deep and then run fluid through that, and then that's your medium to extract the heat or the cool from for your home. Los Alamos and White Rock uniquely ill-suited to drilling. If any of you have been involved with the regional water wells and trying to go through unconsolidated cobbles and basalt and inclusion, it's just, do not think you can do that. It cannot be done in our situation. It's nice if you're in North Carolina where you have alluvials and you can do something like that. One comment about air source heat pumps and capacity. Air source heat pumps are the capacity is set at sea level, where there are a lot more dense molecules in a cubic foot of air. Once you come up to 7,000 feet, you're running 23% fewer molecules in a cubic foot of air, and this is an air source heat pump, so your efficiency, so your capacity at our elevation is diminished on the order of 25 to 29%. So if you think you're getting a 30,000 BTU unit, you can see on the internet, that's what it says, multiply it by 0.71 or 0.75 and say, what does that mean at my White Rock home or my Los Alamos home or my Jemez Springs home? Because we are at high elevation and there's a pretty significant derating that has to be done in your engineering design.
I had a question. You were talking about these units need to be running to work properly on there versus something that's just on demand. What kind of life is there to these units, and what kind of maintenance do you think they need? Overall, a regular burner that could run 20 years or something like that.
That's another good question. When I say the unit is running, it simply means it's on. So let's see what it's going to be. Let's imagine we're in the winter time. What does it mean when it's running? If your home is already warm, it's modulating, and what has happened is the outdoor compressor is not even turning the fan. It's just feeling the air inside your living room. The unit inside your living room is feeling the air, barely turning the fan just enough to bring molecules of air across the thermistor up top to feel the air and see if your set point is still very close to the current temperature. If you get off by 1 degree and now the room has cooled down 1 degree, it sends a little bit of refrigerant to warm up that coil, and then turns the fan a little bit faster to bring the air temperature right back to your set point of 70 degrees. The outdoor unit, the fan starts turning gently like this to get enough warmth in that refrigerant to bring that room back up 1 degree, and it goes right back into standby. So it's not really running, it's not working, It's just monitoring the situation moment by moment, and only if it needs a little refrigerant will it send some. Only if it needs to turn the fan will it send it. And so very low, it doesn't wear out anything.
So it might be working 10 to 15% of its normal.
Yeah, that's the beauty.
So the lifetime of these things is really not that short.
Exactly. These have the same lifetime of a well-maintained gas furnace, you know, properly maintained 15 to 20 years, 25 years. The warranties are 10 or 12 years, just full parts warranties. So it has as good or better warranty than gas furnaces.
Is there any normal maintenance to these things that have to be done every?
Actually not. You know, it's an air source situation, so don't let your deciduous maple leaves cover the back of the coil. Don't let the cottonwood trees coat the back with a ½ inch of flannel, because it's trying to blow air through a coil. So you can hose it off with a hose, you could blow it off with a blower, or just sweep it off, you know. That's sort of what you're looking for, you know, in that sort of thing.
Sue, did you have any input? You were inching.
I just thought of yet another use for ours that may partly tie into that. The other things that these units do that we haven't touched on, or that mine does anyway, in addition to heating and cooling, it will also just run a fan. It will also dehumidify. Not a thing we use a lot of, but I will say that in the summer, having each of these interior units provide a nice fan often obviates the need for even turning on the AC component. Usually at night I'll just run the fan, so you can think about getting rid of the portable fans in your house as well, because you have these, they're quiet, they're adjustable, and they're very nice for cooling off in our dry climate.
Any last minute burning questions?
Was there a need to like improve the insulation of the house before you put them in? Because I'm in a group 16 house and the insulation's pretty awful, probably like 2 inches in the attic and single pane windows.
I have my mic on, so I'll say absolutely yes, that's the first thing you should do, if you can. And we're going to have some workshops and panel things on insulation coming up, right? I think.
Yeah, I'll do a quick plug. Next Thursday, thank you. I have so many events right now. Next Thursday, here at 6:30, we're going to have an insulation expert come and talk about kind of the hows and whys and who's and everything you need to know. The one big benefit right now is if you insulate properly, then you're reducing that heating load, so you might get away with a slightly smaller system based on insulation needs. But anybody else want to add to that?
Before I went for the heat pump, I changed all my windows were installed in 85, and they're 4x4, 20 of them on the south side, and I had to change all of them. So speaking of cost, that really sets you back, but it makes a huge difference just insulating, and yeah, but it still didn't get rid of that 56 in the winter. So now the heat pump does.
All right, I'm going to ask our panelists. That's a great point that I was going to mention, so thanks. There is funding available, if you didn't hear her, through ECAM, the ECAM. You can Google that. That'll lead you through the state's rebate program. Like it was mentioned, it goes off of area median income, and it's 80% below area median income, which is quite high here, so a lot more people are eligible than you might be in other locations based on your income. We're going to be pushing out a lot more information if you don't want to do research yourself, but by all means, go check out their website. It's really good. They keep rolling out items. The heat pump stuff is coming. They have EV stuff. They have windows and doors and a lot of information. And if you don't qualify for the rebates, a lot of that is also available through tax credits as well, if that's something that's interesting to you. Do you have something to add? Yeah, that's a good point. All things have to be a certain model or a certain product, so make sure if what you're looking at is, and you're really interested or really need that rebate or credit, that it's squared away with that website, and it'll tell you on there what products are eligible. So don't just go get whatever and then get it installed and expect money back. My last question for the panelists, because we're almost out of time, is what would you tell others to consider or wish you would have known before switching, or what would you have done differently if that applies to you for your system?
Don't undersize it, and don't wait to install it. When I think about the 20 years we spent moving space heaters around our home and not occupying parts of it and being too cold in the winter and too hot in the summer with our existing system, I wish we'd done it sooner.
If pressured by your partner, don't wait to install it.
That's right.
You have one.
I have one. Yeah, I guess I really don't have anything to add either, I would say. I'm very pleased with it, and the gas furnace was just unacceptable in our situation.
Do heat pumps save marriages?
Yes. Well, at least
That's a key question.
that's the only problem.
If anybody else thinks of any questions that you're just not quite sure how to answer, you can come up and talk to me, and we'll make sure we get that answered through them, because I don't want to waste everybody else's time. But by all means, if you think of questions, we will certainly get them answered, because if you have it, likelihood is somebody else has that same question.
And I'll stay as long as you want.
Sure.
All right. Well, you can leave if you want, but our panelists want to stay. Thank you, everybody.